In this video, we're gonna talk about the rational function and the technique that we're gonna integrate the rational function, which is called the partial fraction. So the point for this section turned out to be you would want to integrate the function in the form of the quotient of two polynomials. So you have x cubed plus 2x squared minus 2x minus 2 over x squared minus x. So you see that the degree of the numerator is equal to 3 and the degree of the denominator equal to 2. So this one is called numerator. And the bottom is denominator. So you see that in this case, you have the degree of the numerator is more than the degree of the denominator. So the top part, normally we're going to call this guy nx. And the bottom part, this guy will be dx. Okay, so you have nx over dx. And you're gonna have the degree of nx equal to degree of dx is smaller than the degree of nx. Okay, so this one is the degree of the polynomial. And this guy is equal to 2, this guy is equal to 3. If you have this situation, we gonna perform a long division. So what is a long division? So we're gonna perform a long division in order to be able to find the quotient and the remainder. So we see that we're gonna reduce the degree of the numerator, and it's gonna make the degree of the numerator smaller than the degree of the denominator. Okay, so we need that first. So let's do this one first, and I'm gonna explain why do we need this guy. So for the long division, you're gonna use the numerator. So you're gonna perform the numerator nx here, and you're gonna put your denominator dx outside like this, and you're gonna find the quotient that you're gonna put on top here. So it's gonna be the quotient, and the thing that you have at the end is gonna be the remainder. Okay, so this is gonna be that we're gonna do this one. So how could we do this one? So it's gonna be just you're gonna just perform long division. So you just put x cubed plus 2x squared minus 2x minus 2. Okay, and you have the divisor equal to x squared minus x. So you're gonna use x squared divide x cubed. Okay, so you have x squared divide x cubed. X squared divide x cubed equal to just x. Okay, and you're gonna have this x multiplied with x squared and multiplied with x. So you would get x cubed minus x squared. Okay, and you have 2x squared minus, so this side turned out to be the minus side, and you see that it's going to be 2x squared subtract by minus x squared. So this one would give you 3x squared. Okay, and you have x cubed subtract by x cubed, so it's gonna be 0. So we just have 3x squared, and you're gonna pull down 2 minus 2x, so it's gonna be minus 2x. So you pulling this one down. Okay, and you're gonna have x squared divide 3x squared, so you would get minus, oh, you get plus 3. Okay, so you have plus 3 from, you just have x squared divided by 3. Okay, so you get plus 3. So you would get 3 multiply x squared, so you get 3x squared, and you have 3 multiply negative x, so it's gonna be negative 3x. Okay, so this is how we have this one. And then what? And then you're gonna subtract these two guys, so you would get negative 2x minus 3x, so it's gonna be just x, and you have this one, you multiply negative 2x. Okay, so it's gonna be negative 2, and this one will be your remainder. Okay, so this one will be your remainder. Okay, so you have the remainder, and the part on top here is called the quotient. Okay, so you have quotient and the remainder. So how could we have this quotient and remainder in terms of fraction? So you see that this guy, what does it mean to have the quotient and remainder in this way? It means that you have x cubed plus 2x squared minus 2x minus 2 will be equal to the green guy, which is x squared minus x multiplied with x plus 3. And you're going to have the remainder x minus 2, which is something like this. Okay, so this is how we interpret from this symbol into the symbol that you have this guy equal to x cubed minus x multiplied with x plus 3 plus x minus 2. And you're gonna divide the whole thing by the divisor x squared minus x. So you divide the whole thing by x squared minus x. Okay, and you see that you just have this one, and you see that this one can be written as x plus 3 plus x minus 2 over x squared minus x. Okay, and if you would like to integrate this function, so if you would like to integrate this function, it's gonna turn out that you're gonna integrate. Okay, so if you would like to integrate this function, it's gonna turn out to be equal to, okay, so you're gonna just integrate this guy instead. Okay, so this is what you have. And you see that we'll be able to perform long division for any rational function that has degree of the numerator is more than the degree of the denominator in order to obtain the quotient that has degree smaller than the degree of denominator. Okay, so this is the conclusion in page 1 here, that if you have the degree of the numerator turn out to be more than the degree of denominator, the thing that you can do will be you'll be able to divide, okay, perform long division, and you would get the quotient. And okay, so this guy is the quotient plus by the remainder over the divisor. Okay, so this guy is the remainder, and your dx is called the divisor. Okay, so this one look like that. Okay, so the conclusion on this page will be that we will decompose only fraction for which the degree of the numerator is smaller than the degree of the denominator. Okay, so this is the thing that we're gonna try to decompose. So we're gonna decompose the partial fraction of the rational function that the degree of the numerator is smaller than the degree of the denominator only. And the way to decompose is going to turn out to be, if you like to find the partial fraction decomposition, it's going to consist of 3 steps. The first step turn out to be you're going to factor dx completely into irreducible factor. Okay, I'm gonna do example with you. So you have x minus 2 over x squared minus x. So let me use this space here. So you have x minus 2, x minus 2, x minus 2 on top over x squared minus x. And for this guy, it's going to be x minus 2 over x minus 1. Okay, so x minus 2 over x minus 1, like this. And you're gonna factor the bottom completely. As you can see, you factor the bottom completely. Okay, and then you see that you're gonna have the factor in terms of linear and linear. So this one, what is linear? Linear is degree 1. Okay, so this one for each linear factor, so linear factor is degree 1. Okay, so you have degree 1. So for example, you have a plus b to the n. So degree 1 that I mean is that the degree of this function. So you see that it is degree 1. It's not involving to the n. To the n is going to be the multiple. Okay, so I'm going to just have the factor, and this one will be your multiple. So multiple. Okay, so MUL, okay, so it is multiple. Okay, so you have the multiple here, it is your n. Okay, so you have your multiple, and this multiple is your n. Okay, so the thing that we call the factor turned out to be just ax plus b, and that guy is linear. And another kind of factor that you're gonna have turn out to be quadratic. Quadratic is ax squared plus bx plus c, and this guy is called quadratic. So quadratic means degree 2. Okay, so you have degree 1 and degree 2, and you have the multiple turn out to be your m. Okay, and you're gonna decompose linear factor in terms of constant on top. So you have this A1, A2, and A3. So here they are constant. And you have each bottom turn out to be power of ax plus b from 1 to 3 until n. So this one will be, you see that it's going to be x plus b, x squared, and a plus b to the n. So it's going to be the factor, not the factor, the power of ax plus b. So it's going to be ax plus b, a plus b squared to x plus b to the n. Okay, and for each quadratic factor multiple, so multiple of quadratic factor, you see that it's going to be quadratic square, quadratic to the m. So you're going to have decomposition m term. And on top, you see that it's going to be linear. Okay, so it's going to be linear on top, and you have quadratic on the bottom. Okay, so you have to decompose in this form. And the next thing that you're going to do is going to be you're going to try to solve for a, b, and c respectively. So let's see what's going on here. So we like to decompose the following rational function into partial fraction. So you first look at the denominator. So you see the denominator here, x plus 3, x minus 2. And for this one, you're gonna have linear and linear. Okay, so you have linear and linear. So you're gonna have x plus 3, x minus 4. Okay, so it's gonna be x plus 3, x minus 4. So you see that this one is linear, this one is linear. So on top, it's turned out to be two constant, a and b. Okay, so it's gonna be just constant on top. And this one is the decomposition. Okay, and the next thing that we're gonna do is gonna be you just gonna solve for a and b. The second one, you see that if you take a look at the denominator, you have linear for this term and you have quadratic for this term. Okay, so when you decompose this one, so you have x plus 3 and you have x squared plus 4. Okay, so you have x plus 3 and you have x squared plus 4. So you get a, which is constant. Okay, so this guy is constant. And this guy on top of x squared plus 4, it must be linear. Okay, so I'm going to just say linear first. And in order to be linear, it's going to be the degree 1 factor. So it's going to be bx plus c. Okay, so this is the decomposition that we will get. The next one, okay, so you take a look at the bottom again. So you see you have x plus 1 to the third. Okay, so you have multiple in this case. So this one is called multiple. And for this one, you decompose this guy into 3 terms. So you get x plus 1, x plus 1 square, and you have x plus 1 to the third. Okay, so you have x plus 1, x plus 1 square, x plus 1 to the third. And you see that we not gonna care about the multiple. So this one is multiple 1, this one is multiple 2, multiple 3, but we don't care about them. We're gonna care only they are linear or not. So you see that you have x plus 1, x plus 1, and x plus 1, and they are linear. So when you have linear on top like this one, is going to be A, B, and C, and you would just have constant. Okay, so you just have constant. Okay. So it's going to be constant. Okay, and this guy is constant. Okay. Yeah. So for this one is your constant. Another one, you see that it's going to consist of multiple. Let me highlight the multiple. And you have this one is linear. And this one turned out to be quadratic. Okay, so this one is linear. So you see that it's gonna be, you're gonna decompose this guy in terms of x minus 1, and it is only one term because this guy is gonna be to the first, and you're gonna have quadratic x squared plus 5 and x squared plus 5, two terms due to you have multiple equal to 2. So this one is your multiple. Okay. And for this one, if you have linear on the bottom, you're going to have constant on top. Okay, so this one turned out to be constant. And if you have quadratic on the bottom, you're going to have linear. So you would like to write bx plus c and x squared plus y squared. So it's going to be dx plus e. Okay, and you see that you have linear on the numerator. Okay, so this is how we do the partial fraction decomposition. This one is just the decomposition. The next thing is going to be you have to solve for A, B, C. Okay, so you're going to solve for the constant. I'm going to do 4 example after this. Okay, it's going to be 4 example that I'm going to perform the partial fraction decomposition with you. The first one, you see that it is x minus 2 over x times x minus 1. This guy is linear and linear. Okay, so when you have these two linear, you're gonna decompose this guy as x plus x minus 1, and you're gonna have linear, which is a b like this. Okay, so this is what you have. And then in order to solve for A and B, the thing that I will do will be you're gonna multiply the whole thing by x times x minus 1. Okay, so you multiply by x times x minus 1. And you see that if you multiply this term, this will get rid of this guy and you will have the green one left. So you get x minus 2 equal to, okay, and you multiply this term, so x will get rid of with x, x minus 1 will get rid of with x minus 1, and you not completely be able to get rid of them out. So the thing that you're gonna get rid of is gonna be a. Okay, so I'm gonna use the red color here. So it's gonna be a multiplied with x minus 1 plus b multiplied with x. Okay, so you have b multiplied with x. Okay, and then in order to solve for a and b, the thing that we're gonna try to do will be we're gonna plug in x such that we be able to eliminate a or eliminate b. Okay, so we're gonna put x equal to the number that you be able to eliminate a or b. So you put x in this case, so you're gonna put x equal to 0. Okay, so you put x equal to 0 for this term. Put x equal to 0, this term disappear. Okay, so you put x equal to 0, you see that this term is disappear. So this will allow you to be able to solve for a. Okay, so this is the thing that you might need to see first. So you put x equal to 0, you get 0 minus 2 equal to a, 0 minus 1 plus b times 0. And this term turned out to be disappear. Okay, and you have negative 2 equal to negative a. So you would get a equal to 2. Okay, so you have a equal to 2. And the next thing that we gonna have is gonna be we gonna solve for b. In order to solve for b, the thing that you see is gonna be if you like to eliminate a, it's gonna be you're gonna put x equal to 1, as you can see. Okay, so you're gonna put x equal to 1. If you put x equal to 1, you'll be able to get rid of a and you'll be able to solve for the rest. So you're gonna put x equal to 1. So you put x equal to 1. So you would get 1 minus 2 equal to a 1 minus 1 plus b times 1. and this term disappear. Okay, so you're gonna just have b equal to -1. Okay, so you have b equal to -1 and a equal to 2. Okay, so they are like this. And then what? And then you're gonna have x minus 2. So you have x minus 2 over x squared minus x equal to the decomposition. So you're gonna put a and b back into the decomposition here that you have. Okay, so you're gonna put a and b back up there. So it's gonna be 2 over x plus -1 over x minus 1. Okay, so you have this decomposition, and you see that this guy is 2 and -1 that you have been finding. Okay, so you have this one, and you're gonna be able to use this decomposition in order to find this integral. So if you like to integrate, okay, so if you like to integrate, recall that the thing that we did so far, we would want to integrate this guy dx. Okay, so when you integrate this one, so you would get 2 log absolute x. Okay, so this is just 2 over log absolute x. And the next thing will be negative log absolute x minus 1 plus c. Okay, so you'll be able to integrate this guy, and it's turned out to be 2 log absolute x minus log absolute x minus 1 plus c. Okay, so we're gonna integrate this guy. Okay, so you see that integrate x is gonna be x squared over 2. Integrate 3 is gonna be 3x. Okay, so it's gonna be 3x. So this one will be 2 term here. And you integrate x minus 2 over x squared minus 1. It's gonna be, you just have 2 log x absolute minus log absolute x minus 1 plus c. Okay, so this is how we have the final answer. Okay, so this is the thing that we try. And the technique here is called partial fraction decomposition. Okay, so this is the name of the technique. It's called partial fraction. Partial fraction decomposition. Okay. So let me help you a little bit on the integration by substitution. So when you like to integrate ax plus b, 1 over ax plus b, the thing that you like to integrate will be, you see that you're gonna use the substitution. So we're gonna let u to be ax plus b, and you use the substitution du equal to a dx, and you get dx equal to 1 over a du, and this 1 over a will give you the additional factor over a here. Okay, so this one will be just the integration by substitution. So it's going to be integrate of 1 over ax plus b dx is going to be log absolute ax plus b over a. So for example, if I ask you what is integrate of 1 over 2x plus 3 dx? So this guy, you're gonna answer log absolute of the denominator over the coefficient of x. So it's going to be over 2. This can be done for 1 over linear. Okay, so I'm going to just say that this one is going to be 1 over linear. Okay, the next one will be you have integrate 1 over 5 minus x dx. So for this one, you see that this guy can be written as 1 over negative x plus 5 dx. So this guy will be log absolute negative x plus 5 over negative 1. Okay, so this is how we have this one. And you just identify A, and A in this case is equal to negative 1. A in the previous example equal to 2. Okay, so this is how we have this integral. The next one will be you like to integrate 1 over x squared plus ax squared in order to take care of the quadratic term. So when you like to integrate this guy to take care of the quadratic term, you're gonna use the substitution. I taught you before that this guy can be written as you're gonna pull out a square. Okay, you're gonna pull out a square and you're gonna use the substitution. So this guy will be 1 over x over a square. So it's going to be x over a square plus 1 dx. So this guy can be written like this, and you're gonna let u to be x over a and use the substitution. This is how we integrate. Okay, so the formula turned out to be 1 over a arctan x over a plus c. For example, if you want to integrate 1 over x squared plus 4 dx, so you're gonna write this one as integrate 1 over x squared plus 2 squared dx. So you would get a equal to 2 in this case, and this guy turned out to be 1 over a, which is 1 over 2 10 xe over 2 plus c. Okay, so this is how we integrate this one. Okay, and another thing like I like to teach you is going to be if you have 4x squared plus 9 dx, if you like to integrate this guy 4x squared plus 9 dx, the thing that you're going to do will be you're going to pull out 1/4. Okay, and you end up with 1 over x over, not x over, x squared over 4. Okay, so it's going to be x squared over 4 plus 9 over 4 dx. Okay, you'll not be able to use the formula right away. Okay, you'll not be able to use the formula right away. So the thing that you need to do is going to be you need to use the substitution. For here it's going to be 1/4, and you would let u to be x over 2. So it's going to be 1 over x over 2 square plus 3 over 2 square dx. Okay, so this is how we deal with this guy. Okay, so you'll be able to deal with this guy. I make a mistake, so it's not that hard to do. I thinking that why I'm doing this one so hard. So this one is not that hard. You pull out 4. This is what you get. So you get x squared plus 9 over 4. Okay, so this is what the thing that you should get sorry about before. So this one is going to be 9/4. So this one will be 1/4, and you have 1/x squared plus 3/2 squared dx. Okay, and you have a equal to 3/2. Okay, so you have a equal to 3/2. So when you have a equal to 3/2, you're gonna just have 1/4, and you're gonna integrate. So integrate this one is gonna be according to our formula, a equal to 3/2. Let me change the color. So this one is gonna be the pink one. So you have a equal to 3/2, and then this one will give you 1/3/2. Okay, and it's gonna turn out to be arctan. Okay, x/3/2 plus c. Okay, so you would simplify this one into 1/4 times 2/3 arctan 2x/3 plus c. Okay, and this is how we have the final answer. It's going to be 1/6 10 x not x 2x/3 plus c. Okay, so this is how we integrate 1/4x squared plus 9. Okay, so this is how we deal with these two formula. Okay, so we're gonna continue example 2, 3, and 4, okay, in the next video clip. Okay, so it's gonna be 2, I have to change this one to 3 and 4 in the next video clip. So for this one, it's gonna be 3, and this one is gonna be my 4. Okay, so it's gonna be 2, 3, and 4 that we gonna study next. Okay, so I'm gonna stop at this first, and then I'm gonna continue the partial fraction. Don't forget that how to decompose. If you like to recall how to decompose, you go to this example. Okay, and we're gonna do the partial fraction, 3 more example in the next video.